Okay, welcome to this part. We're gonna just quickly understand how we're gonna make transform more complicated trigonometric functions, and we're gonna use sine as an example here. So the sine function of y equals to a times sine bx plus c. First and foremost, you must understand the effects. What is sine x first? So the basis of y equals to sine x has an amplitude of 1. Okay, I'm so sorry, I just accidentally clicked this. Okay, it has an amplitude of 1 and a period of 360 degrees. So a period of 360 degrees means how long does it take in terms of the angles to form one cycle. So this is actually one cycle. Now with that understanding, we want to be able to solve questions like that now. So what happens if you multiply a value to sine x? So let's take the first example here. I'm going to write y equals to 3 sine x. So what happens is I multiply 3 to sine x. In fact, when you do that, you actually multiply the amplitude by whatever you multiply. Why? Because you think about it, if originally sine x, the maximum value of sine x was 1, if you multiply 3, your maximum value will become 3, and your minimum value will also be the same. It will become you multiplied by 3. So actually, if you multiply anything, okay, to sine x, you in fact just increase the maximum value and increase the amplitude. So in this case, now my maximum value, it will be 3 and my minimum value will be -3. So now my amplitude is just 1, but my period does not change. My period still stays as my period here still stays as 360 degrees because it doesn't increase the x. It's still, to form one cycle, it still takes 360 degrees. Okay, now what happens if you actually multiply a value to x? So for example, I will multiply 2x. What is happening instead, if you see over here, is that as compared to the original y equals sine x curve, you actually decrease the period by 2, by a division of 2. And in this case, your period now is how long it takes to form one period. It just takes 180 degrees, but your amplitude still stays the same at 1. Okay, I'm not drawing to scale, so do take note over here. Now the last one is what happens if you add a value to the entire function. Okay, I'm not adding to x, but I'm taking, for example, y equals to sine x plus 4. Okay, do take note that the x is alone. So in this case, when you do that, as compared to the original sine x earlier, okay, you realize that actually the maximum value was from 1, it increases by 4. So you just translate the graph upwards. So what happens if you subtract a number, you translate the graph downwards. Alright, so taking in mind these 3 different ways to transform any trigonometric function, I'm just using sine as an example here. We can go ahead to try to attempt to sketch something like that. Now, the way to do this is, number 1, you should always think about its period first. Okay, you must always start with adjusting the period. Okay, so a quick way to remember this is to first you adjust the period, then you adjust the amplitude, and then you adjust the max mean value. Just remember Pam. Okay, I hope you don't have a friend called Pam, but you need to remember PAM. You must always start with adjusting the period. So how do you adjust the period? Okay, if you look back at earlier, okay, you can only adjust the period when you multiply or divide a value to x itself. Okay, so that's number 1. Number 2, how do you adjust the amplitude? You in fact multiply a value to the function. Okay, you don't multiply to x anymore. And then the last but not least, when you want to change the maximum and minimum value only without changing any amplitude, you just add a constant to the function itself. So you're going to apply this 3. So let's just relatively just draw it very quickly. So for example, I have a curve here. Okay, I will start from y equals to sine x. Okay, so if I want to change the period, so I have that sine x is drawn from 0. Okay, from 0 to 2 pi, so which is 360 degrees. So it means at this stage here, this is 2 pi. So it takes 2 pi angles, 2 pi angles to actually form one cycle. If I'm going to multiply it by 2x, because I see the question here is 2x, right? So I'm going to make it 2x first. So the second step is to shift this way. Okay, you will realize that now for 2x, your graph, you take this about half the distance, right? Okay, I'm not actually doing it very well, but I think it's something like that lah. Okay, you just need to sketch. So now over here it will be pi. So it takes one cycle takes pi amount of degrees. Now the next, so we have adjusted the period, we're gonna adjust the amplitude. So this was P. I'm gonna go to A. So adjust amplitude. To adjust amplitude, because we have 4 times sine 2x, I'm gonna adjust it to y equals to 4 times sine 2x. Okay, so just multiply 4 towards this guy. What you can actually do is just draw the original curve. Okay, I'm not drawing to scale. I say again, I am not drawing to scale. I should draw to scale, but you don't have to because it is just simply a sketch. Okay, so do your best to draw as similar as possible. Okay, since the period does not change, the period is still pi, but you're increasing the amplitude, right? So when you increase the amplitude, this becomes 4 and negative 4. I know I'm not drawing to according to scale, but it's because we understand that when you do that, you're just increasing the amplitude by 4. Okay, and the last step is to do m, which is the mean and max value. The only way to change the mean and max value is the last step, which is I want 4 sine 2x minus 5. Now in this case, since the sketch is the last sketch, I make it bigger because the last sketch is the final answer, and hence we're gonna start. So if I decrease the entire function of 4 sine 2x minus 5, this means my maximum point will now be negative 1, minimum point will be negative 9, and this middle, it starts from the origin, right? So if you look here, it starts from the origin. It will now start from negative 5 here. So we're going to start drawing from here. Okay, so we go up, come back down somewhere in the middle, go down. Okay, if you're not satisfied, try again. I am not satisfied, definitely. Okay, I mean, of course you could actually use something like that. Okay, so we have drawn something like that. We have drawn it. Okay, so I'm quite satisfied with this. Now, so the thing is, here you have only drawn, okay, from 0 to pi, which is correct, which is one cycle, right? Which is based on the transformation. But what you must understand is that we have asked you to draw from 0 to 2 pi, which means, remember, if you need to draw from 0 to pi for this function, okay, you need to continue drawing, because remember, a sine curve is an infinite curve. So right now you can draw the same thing to draw all the way until you reach 2 pi. Okay, try to make it as similar as you can, as much as you can. Okay, if you can't, it's okay, but don't make it out of shape. Okay, my advice is do not make it out of shape as much as you can. Okay, so if you go out of shape, use your pencil, erase it, and draw again. Okay, something like that. Okay, so now the graph is correct, and it is the graph of y equals to 4 sine 2x minus 5. Okay, so that will be it for this part of the lesson. Thank you.